Welcome CSC103 to our Intro to Programming. This will be Unit 9, and this PowerPoint presentation will just be a way to just kind of give you a little bit of an overview before we start digging into programming a little bit. Now, the logo that you see on the right side there are two snakes. They're pythons, and that's the Python logo because that's a programming language that we're going to be working with to kind of get introduced to programming. Now, first of all, what is programming? Well, the simple answer is you're just providing instructions for a computer to execute. It'll read your code and it'll execute your code. And the instructions are meant to solve problems or perform a task. It could be math operations, it could be analyzing data, it could be anything like that. But it's your job to give the instructions to the computer through programming languages. Now, there's kind of two areas of programming languages that we're going to just mention briefly here. I know there's 3 bullet lists here. There's machine language, assembly languages, and high-level programming. Now, we're going to do high-level programming languages. Now, all that means is low-level programming languages like machine language are closer to the hardware, meaning they're the language that computers understand. And what do computers understand? Binary. Now, you're not going to want to write things in binary. You're going to want to write things in a language that you understand. And if you work in Python or Java or C++ or JavaScript, you're going to understand that a little bit more. You're going to learn the language and be able to communicate a little bit more. Assembly languages was something that was kind of in between. It was another step up from machine language, but it was still very cryptic. Now, here's an example. Machine language, that's what a computer understands, but you don't want to write code in binary. People had a hard enough time just writing out their age in binary, much less trying to write down code that represents where something should be stored in memory and what operation should take place. So what we did was come up with different ways to kind of make things get translated into this language. And one of the first things was assembly language. Now, this was still very cryptic. You could see some of the assembly code here. Load number 2, store number 13. It was still speaking to the hardware. It was talking about memory locations and loading values into the accumulator. Still very complex hardware kind of stuff. It's not just, hey, figure out these test grades or anything like that. We weren't doing that with assembly language. So it was still very cryptic and still very hard for a lot of people to get involved in doing that. So there weren't many people doing this kind of thing. Now, with high-level programming languages, there was less code, more instructions, but it was easier for humans to write and understand. You could kind of figure it out a little bit better. So it wasn't something that took a super long time to understand. Now, what happens with high-level programming languages is you write things in a language that you kind of understand, or it kind of makes sense. Now, it has its own system and structure, but a compiler or some type of interpreter will convert what you write, the code that you write, into code that the computer can understand. And they call it high level because, you're working at a higher level. You're using something closer to the English language. You're not writing things that are very cryptic for a computer to understand. So it's more what humans understand. That's why they call it high level. Now, Fortran was the first high level programming language. That was back in 1954. So these started coming about both in the 50s and 60s. Now, this graph here that I threw in here, this is from 1983. I was in high school back then, and I didn't know anything about any of this stuff when I was in high school. And you'll see languages like Pascal and C, and Fortran was already going down in popularity by then. It wasn't the top language. There were all these new languages coming out. You could even see there was BASIC, which Windows machines were originally created in BASIC. Bill Gates worked with BASIC to write the Windows operating system initially. And you'll also see COBOL. You probably heard of COBOL and C++. Adobe Photoshop and Illustrator were written initially in C++. So there was all these new languages coming out. And some of them are still used. It doesn't mean they're not used anymore. But there's a whole new breed of languages coming out. Here's the top 10 most popular in 2020. And you can see Python has really taken a lead here in front of Java. Java for many years was out in front. And you might have heard of Java being used in high school computer science programs and college computer science programs, also C++. But since then, Python has kind of taken over a little bit because it's easy to get involved in programming with Python. The language is a lot easier to get started with. That's why we use an Intro to Computing and Intro to Programming or Programming 1, because it's a nicer introduction. There's less strict structure as far as what you have to type. It's still very powerful, but there's just some complexity in Java and C++ that you don't have to worry about as much when you start working with Python. It's a very all-purpose language. You could also see JavaScript on this list. That's a language that's used in web development, but it's also used for web servers. It's still very popular. It's been around for a while. And a number of these other ones are newer ones. Some of these other languages have become more popular with mobile development, things like Objective-C and Swift. PHP is popular with databases. So they all have their different kind of uses. Now, here's some of the top languages used by the top 25 tech companies. And you can see Python's up there, Java's right behind, JavaScript is behind there. JavaScript wasn't that high because it was used for web development, but it's also used for server-side development as well. There's different frameworks that people use JavaScript with, so it's still very popular. C++ is still up there, and you can see there's a whole lot of languages up there. There's hundreds of programming languages. There's not just 10 or 15, there's hundreds of languages, but these are the most popular and the most widely used. Python's used for artificial intelligence, it's used for data science. It even has web frameworks that you could use. Java has been popular in mobile development on Androids, and like I mentioned, JavaScript is very popular in the web. Now, just to give you an overview, you're not going to remember all this stuff. I know I'm throwing a lot of languages at you, but again, high-level programming languages, just an example of a few. The top ones would be things like Python, Java, C++, things that you probably have seen taught in high school or college courses. C# and C are also very popular, and they're used for software development, web applications, mobile applications. And then there's JavaScript, HTML, and CSS. Now, they're kind of a different category. They're used in web development, and some of them aren't really programming languages. HTML is a markup language. CSS is a scripting language. Even JavaScript is a scripting language. Keep in mind, JavaScript is not the same thing as Java. They're not even really related. JavaScript is still very powerful, and it's used like a programming language, and it could work on front end of web pages, back end of web pages, and it's used for more things every day. So JavaScript is still very popular, and it's a good language to learn. You could do a lot of things with it, and I think once you learn JavaScript, you could use it to learn other languages very quickly. Also, there's PHP and SQL. Those work with databases. They're languages that can communicate with databases, which are on servers. We'll do a little bit of that in CSC103 as well. Now, I just want to mention the structure and syntax of some programming languages. Now, remember, they're languages. Just like the English language has, you start a sentence with a capital letter, you end it with a period, you use commas and semicolons and all spaces in between the words. There's also rules that you have to follow with programming languages. And some of them are similar and some of them are different. So it takes a little time, but you have to be very specific about it. You can't just put a comma where there's supposed to be a dot or a period. You can't put a semicolon when there's supposed to be a colon. You can't put 3 parentheses. You can't put square brackets where there's supposed to be curly brackets. You can't put an equal sign where there's supposed to be 2 equal signs, because it won't work, because computers only understand the code that you write. Computers can't just assume, oh, you must have meant that. That doesn't work with computers, so you have to be very specific. So again, with programming, now you don't have to be a mathematician to work with programming languages. You just have to be very observant, and you can't make a lot of typos. If you make typos, errors are going to happen. You also have to stay calm. You can't be like banging your keyboard or banging your mouse because things go wrong. Things will go wrong all the time. So problem solving and figuring out where errors are is just part of what happens when you program. Figuring out why isn't this working, that's part of programming. That happens every day. You don't just type something in and it works. You say, why isn't this working, or what can make this more efficient? That's all part of programming. And understanding the language is just part of it. There's a lot more to that. There's problem solving and all that, but just understanding the language, how it works, that's the first part of it. And you'll also see keywords. The language itself has certain parts of the language that are part of that language that you can't name other things, var or function or def, because they're reserved words for that language. There's also data types. Data is just what you're working with. Are you working with numbers? Are you working with strings, which are really just words? Are you working with lists? Are you working with objects? Are you working with Boolean, which is true, false? So all these kind of things are called data. That's what you're working with. Now, this might not mean a whole lot yet, but you'll see this term a lot with the functionality of programming languages, algorithms. And algorithms are really just step-by-step instructions to complete a task. We're going to use the turtle module because we'll have basically little turtles that you could make move around and do different things and give them instructions. And you'll learn about instructions by using these turtles. You'll learn about algorithms. You'll learn to use functions, which actually just kind of collect these together in kind of a named list, kind of like a recipe or shopping list of things that you're working on. So you could create functions that can be reused. We'll use variables, which are basically just words or letters that hold data. So if data is changing, you have a variable that represents something. So whatever, it could be a salary, it could be a certain number that's changing its value, it could be test grades, anything like that. But a variable just represents that. The variable means that it's changing, means that the data it's holding is going to be changing. So you don't want to always change the data. If you use a single variable, it could represent a lot of things that are constantly changing. Just like if you ever work in Excel and you're using formulas, you don't want everything changing all the time. You want to be able to plug numbers in, and that's what variables can do. Now, just one last thing I want to mention here, coding versus programming. Programming at the bottom here involves more problem solving, completing tasks, operations, being more efficient. It can get very complex. There's a lot of data involved. That's more programming. Coding, now you may have done coding. Just putting an HTML web page together involves coding, and it's not easy. There's a lot of little details to remember. Knowing a markup language takes a lot of time to understand how that works. There's CSS, which does the formatting and the layout. There's a lot of work involved in both, but programming involves a little bit more problem solving, whereas coding, you're putting together data that just shows up a certain way on a page. I guess that's the way I'll put it. So, it's good to know both. It's good to be a good coder if you're programming, but, just doing HTML code isn't necessarily programming. There's more involved in programming and even math. Sometimes I say you don't have to be a mathematician, but there is math involved because that's why people do programming, to solve complex problems. And if all the problems were easy, then you probably wouldn't need programming. So just showing a little difference there between coding and programming. And we're going to start working with Python. We're going to be just doing some basic coding and then start working with Python using the Trinket IDE.